On this Explain It, we're going to show you how to calculate average atomic mass. Here are 3 examples of elements that we are going to calculate their average atomic mass. We have listed here the mass of an atom right here, and then we have its relative abundance. So for carbon, we have listed 2 isotopes. Carbon 12, that is in abundance 98.89%, so that's most of the carbon in the world. And the second isotope has a mass of 13.003, and its abundance is only 1.11%. So we're calculating that red number on the periodic table that's underneath each element in a square on the periodic table. Average atomic mass. Now remember, if it's average atomic mass, that doesn't mean any isotope could actually have that mass. We're taking the weighted average of the isotopes, naturally occurring isotopes, and calculating their average atomic mass. And remember, it's a weighted average. So if it's a weighted average, we have to take into account this percent. So if we want to use a percent and multiply, we have to first change the percent to a decimal. In order to do that, we will take the decimal and we will change it by moving the decimal 2 places to the left, 1, 2. So the decimal point is now here. So what you're going to do is you're going to take the mass and times it by the abundance, and you're going to write the answer over here. So if we take 12 times 0.988, okay, remember this is a decimal point, 0.988, we get 11.8668. And we're going to ignore sig figs for a little bit here. Now we're going to do a second isotope. We're going to take 13 times this percent changed to a decimal. So we're going to have to move it 2 places. So we have a decimal point here. And don't forget you have to add a 0 in here. So 13.003 times 0.011 gives us a number that looks like 0.14433. All right, so now we have that isotope 1 contributes 11 AMUs, and isotope 2 contributes 0.14433 AMUs. And if we add these down, we get a number, and we're going to round to the 100th here. Generally, when you're working with the periodic table, it's okay to round to the 100th. And then don't forget the units. The units are AMUs. AMUs. All right, so what did I do? I changed the percent to a decimal. So step 1, change the percent to a decimal. Step 2, multiply across. And the last thing we did was we added down. So add down. Multiply across, add down. That's the pattern. Let's look at the second one. In the second one, we have the abundance here. So we have to take our percent and change it to a decimal. So in order to do that, we move the decimal 2 places to the left. The decimal's here. And now we're going to multiply across. When you multiply across, you get a number that, let me get a different color. You get a number that looks like 26.412. Let's do the same for the second isotope of chlorine. We're going to move the decimal 2 places to the left. We're going to multiply across, and we're going to get 9.046. Once we have multiplied across, we're going to add down. When you add down and round to the 100th, we get 35.45. And we're going to use AMUs, atomic mass units. Atomic mass units. All right, so what did we do again? Let's remind you what we did. We took the abundance, we changed it to a decimal, then we multiplied across, and lastly we add down. One more example. Let's do silicon. All right, silicon, it has 3 isotopes. So step 1, move the percent to a decimal, multiply across, we get 25.798. take this decimal, a percent, change it to a decimal. You have to add a 0 in front, multiply across. 1.3619. Again, take the percent, change it to a decimal. You have to add a 0 for this one. Multiply across. 0.9262. Next, we add down 28.09, and then you must have units, AMUs, atomic mass units. And that's it. That's all you need to do to calculate average atomic mass. You'll have some practice problems to do. Good luck.